And I really just don't sit, I just stand at a big table. Okay, so here we go. I have to write down the I can statement for 4.6. This lesson today is going to be how to calculate the area and the perimeter of a polygon. So here we go. I can find the perimeter of a polygon. Polygons are what? Just closed figures, right? So triangles, rectangles, parallelograms, squares. Those are the ones that we're focusing on. I can find the perimeter of a polygon and the area of a triangle or a quadrilateral given a set of coordinates. So I can calculate the perimeter of a polygon. Even if my polygon has 5 sides, tell me what perimeter is. Owen.
It's all the sides, right, added up.
Yeah, you add up the length of the side, right? So you just kind of follow it around and you add up the length of the side. Area. Area is a little bit challenging because you have 3 or 4 formulas that you have to know, right? Area is a little trickier. So we're going to start off by writing the formulas down for area of the shapes that you're going to have to calculate the area for, okay? So who remembers the area formula for a triangle? How do I find it? Sandra?
I think it's like base times width or length times height, so like that.
That's volume. Length times width times height. That's volume. So that's a shape that's 3-dimensional because you're multiplying 3 things. This is a flat shape, so it's just 2-dimensional. It does not involve pi. That's a circle. Circles with. So a triangle kind of is length times width. We call this measurement the base, and we call this measurement the height. Base times height, but we do something with it. We divide it by 2. So the area of a triangle equals the base times the height divided by 2. Okay. So notice that the base and the height form a what? What are they forming? Yeah, they're forming a right angle. So what about that other triangle that I have drawn there? I know that this is the bottom, so we can call this the base. But I don't see a right angle in that one. How am I going to find the height of that shape? Go across the middle. Awesome, Lysandra. We're going to draw a dashed line from the top vertex, the tallest point, down through the middle. And we want it to be perpendicular to the base. So in this example, our height actually goes through the middle. Okay? That can be tricky sometimes. Sometimes, maybe all the time. Okay? Talk to me about a rectangle. How are we going to find the area of a rectangle? I'll mark the measurements. You have a length and you have a width. Length times width. That's it. Length times width. You guys have been doing that for quite a while. We've done a lot of questions with area and perimeter of rectangles. Okay. When I look at this parallelogram, it kind of looks like a rectangle that got like squished. Doesn't it? So this bottom, if you compare, like, if you were to compare the parallelogram to the rectangle, they kind of look the same, except the parallelogram kind of like leaned over to the side. So this bottom measurement, which is equivalent to the length here, we call that the base. You can think of it as the length. It's the same thing. But the width is the height, because if you think about a rectangle, this is a right angle. So we also need to find the height of this guy. So the area of a parallelogram, and I'm just going to put area of a para, is base times height. What about that last shape? All sides are equal, okay? It is a quadrilateral. We know that these make right angles, right? That's what a square has. So, if I label this side as S, just for the side length, how could I find the area of a square? Base times height. Okay, so if this base is S and the height is S, what's another way to write that? S squared. I love that. Good job. Okay. So we are going to find the area of our shapes first, and then we're going to find the perimeter. Because these are not nice shapes. All right, we're going to find the area first and then the perimeter. So is everybody good with that? Who needs more time? Okay. So our first shape looks like this. Quadrilateral PQRS is graphed below. We have to find the area and the perimeter. So we're going to find the area first. And then on your little graph paper that you have, we're going to find the perimeter. Okay, because we're going to have to draw on this shape. We're going to have to do some drawing. How in the heck am I going to find the area of that? That is not a rectangle. It's not a triangle. What do you think? What do you think, Kenna? I need you to pay attention. Stop talking. Or this is your seat from now on. I'm not tired of asking, okay? It's not a parallelogram either. So I'm going to show you a trick, okay? This is probably the best way to do this. So we're going to go from the lowest point all the way across. So we're going to draw a horizontal line. And then once I get right below R, I'm going to go up to Q, all the way over past P to where it lines up with S and straight down. What did we just create? A rectangle. We just created a rectangle. Do we know how to find the area of a rectangle? Okay. So let's find the area of a rectangle first. So I know that that's going to be the length times the width. So I'm just going to count. What is my length? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to mark that. Has a length of an 11 and it has a height of 1 or a width of 1, 2, 3, 4, 5, 6, 7, 8. So if I want to find the area of this rectangle, I'm just going to take 8 times 11, which equals 88. I know it's units squared, but we're not done with that. We're not done with that. Okay? By creating that rectangle, what did we add to the shape? We added this shape right here. We added a right triangle on the left side. Awesome. And we also, I don't know if you can see it or not, but we also added a right triangle right down here. We added those to that shape. So really, we want the area of the white space, right? So if I know that the area of the whole rectangle is 88, what could I take away from it to find the area of just the white space? Two what? Two, what two shapes did we add? We added two triangles. So now we have to subtract the area of the two triangles that we actually created. We created those triangles by extending our lines and making a nice rectangle. But we added that to our shape, so we got to subtract it out. Does that make sense? Okay. So let's figure out the area of the first triangle. So I'm going to say area of triangle number 1. And I'm going to call this triangle number 1. Well, the area of a triangle is the base, 1, 2, 3, times the height, 1, 2, 3, 4, 5, 6, 7, 8. So 3 times 8 divided by 2. What is 3 times 8? Feel like you can grab your calculator. 24 divided by 2 is 12. So the area of the first triangle that we created has an area of 12. We added 12 square units onto that shape. Okay. Let's find the area of the second triangle that we created. Let's see. It has so this is the second triangle that we created. Let me write that on block so you guys can see it. This is the second triangle that we created. So let's see. It has a base of 1, 2, and a height of 11. So 2 times 11 divided by 2.
So 2 times 11 equals 22.
And 22 divided by 2 is what, Owen?
11.
Okay. So by turning that quadrilateral into a rectangle, we actually added 2 triangles. We have to subtract them out. So the area of the rectangle minus the area of the first triangle minus the area of the second triangle is going to give us the area of our polygon. So what'd you get, Lissandro? 65. So the area is 65 square units. That's a really cool trick, and it's extremely helpful when you have a weird shape. Turn it into a shape that you can work with, right? We can all work with a rectangle because typically you create right triangles by adding, okay? Does everyone feel good about that? All right. So now what I want you to do is redraw that shape. Does anyone still need this up here? Okay. On your graph paper, Michelle, are you still looking at that? You're good? Okay. So on your graph paper, the piece of paper that I gave you, I want you to redraw this shape. I want you to redraw this image at the top. So you're going to draw it on your graph paper. Draw it on your graph paper. Do you want me to label the points for you? Will that be easier? Yeah? Okay, I will. So R is the ordered pair 6, 2. I'll write them up here. R is the ordered pair 6, 2. That's a horrible looking 6. Q is the ordered pair 6, 8. P is the ordered pair -2, 8. And S is the ordered pair -5, 0. So plot those points on your graph paper. If you want a ruler, I've got little plastic rulers, I can pass those out. But now we're going to calculate the perimeter of that. We're going to calculate the perimeter of that. Because we haven't calculated the perimeter of that. Anyone want a ruler? Ken, do you want a ruler so you're not using your... No? Okay. Anybody else?
Yes, please, thank you.
Okay, yeah. So connect your ordered pairs. Make that polygon. Ladies, I'll set some rulers up here just in case you want them. Okay. So we're going to have to calculate the perimeter, which is all the way around the outside. Well, are there any measurements that we can count because they go along a horizontal or a vertical? Owen.
Well, we can measure the QR and the PQ.
Yeah, we can count the measures of QR and PQ. Let's see. Q to R, 1, 2, 3, 4, 5, 6. So Q to R is 6 units. That we can count. P to Q, 1, 2, 3, 4, 5, 6, 7, 8. So P to Q is 8 units. That we can also count. We love it when we have horizontal and vertical lines. That makes our lives way easy, right? Okay. How in the heck are we going to calculate those diagonals? Well, what did we do to them before? What did we turn those into up here?
A right angle.
We turned them into right triangles. Do we know how to calculate the missing side of a right triangle? Huh? You don't? Yeah, you do. Pythagorean what? Yes, good job. Okay. So we're going to turn this right here into a right triangle. I'm going to call this side that we're missing X. What is the measure across the top? What did we just add to this?
We added 3.
We added 3 units. And what did we add going up and down? I think we added 8. 8. So let's see. Pythagorean theorem, 3 squared plus 8 squared equals x squared. Okay. Huh? You can, yeah, just write it on your graph. Just write it on your graph. So what is 3 squared? 9. Whoops. So I have 9. I really want that to be purple. 9 plus, oh my goodness, cooperate with us today. 9 plus, what is 8 squared? Okay. Equals x squared. Yes, it's 73. And I know that if it's x squared and I want to get x all by itself, what do I have to do? Square root it. So really, x is the square root of 73. So this side that we just calculated right here equals the square root of 73. Okay. We have one more side that we have to calculate. We got to figure out this guy right here. Can I also turn this into a right triangle? Yeah. Yes, I can. What are the dimensions of this right triangle? Well, it's 2 high and 11 long. That's 2 by 11. So 2 squared plus 11 squared equals y squared. I'm going to call our missing side that we're trying to find y. So we're going to try to like smush some steps together because you guys are working on graph paper. What is 2 squared? 4. And what is 11 squared? What's 4 plus 121?
25.
So 125 equals y squared. If I want to get y all by itself, what do I have to do? Take the square root of it. So y is equal to the square root of 125. So our perimeter, add up all the sides, is 8 plus 6 plus the square root of 73 plus the square root of 125. Put all that into your calculator because it says just give us the perimeter to the nearest tenth of a unit.
212.
That is not what I got. So these are square roots. Do you see that? These are square roots. So you have to turn that 73 and that 125 into a square root. What did you get? That is what I got. So I'm going to turn this equal into a little squiggly because it's about, we're rounding, it's about 33.7 units. That's tough, right? We learned Pythagorean theorem 2 weeks ago, lesson 4.3, Pythagorean theorem. Okay. Maybe last week, but I think it was 2 weeks ago. Okay. So now what are you thinking? Do you feel good about that? Okay. Let's go to the next shape. So our next shape should look like this right here. This is at the bottom of your journal. Do you guys see it? Yes, no, maybe so?
Yes.
Okay. So given the coordinates A, B, and C, find the area and the perimeter of this triangle. Well, what do we have to do first? We actually have to plot the points on this one. So I know that some of us are still struggling with plotting points. Remember, I've been saying this every day. So this is negative. The x coordinate is negative. That means I'm going to go start at the origin and go left. And then my y is positive. I'm going to go up. So left, 1, 2, 3, 4, up, 1, 2, 3, 4, 5, 6. So here's point A. Point B, let's see. Negative means I go left and negative means I go down. So starting at the origin, I go left 1 and down 3. Point B. C, positive, negative. Positive means I go to the right, the x-coordinate goes right. Negative means the y goes down. So from the origin, I'm going to go to the right. 1, 2, 3, 4, 5, down 1. This is point C. Again, we have to find the area and the perimeter. We are going to find the area first, and then we'll do the perimeter on our graph paper. So we're going to find the area on this one, and then we'll find the perimeter on the graph paper. Ma'am? Yes, can you write yourself a pass, honey? You write her pass, Kylie Cook. Kylie Cook. All right, so look at what we did on the top. If we have a shape that's not easy to calculate, right? We don't have some exact lengths that we can count along a vertical or a horizontal. How are we going to do that? Turn it into a
Square.
or a rectangle. Yeah, we're going to have to turn it into some shapes that we can manage. So the leftmost shape, the leftmost side is A. So this is going to be the left side of my rectangle. Then I have to go across the bottom to here. And then I have to go up all the way to where I meet A again. And so here is my shape. I'm going to have to turn it into a rectangle, something I can work with. Okay. So can we count the length and the width of our rectangle? We sure can. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, sweet. So So this is a square, Ken. Awesome job. So the area is 9 times 9, which is 81. But when we created this square, we actually added how many triangles? We added 3 triangles this time. You guys are awesome. We added this triangle first. This is the one that I'm going to calculate the area of first. We're going to call this triangle number 1. Okay. So the area of triangle number 1. Well, it's 9 across times, let's see, 1, 2, 3, 4, 5, 6, 7 divided by 2. What is 9 times 7 divided by 2? Owen?
So 9 times 7 equals 56.
63.
63. Divided by 2 is
It's 31.5.
It's 31.5. Good job, you guys. Awesome teamwork. 31.5. So that's the first triangle that we're going to have to subtract out. Which one do you want to subtract out next? The one on the bottom or the one on the left? The bottom? Ken said the bottom. So here we go. All right. So the area of triangle number 2, I'm going to call this number 2. Area of triangle number 2. Let's see. It's 2 units tall by 1, 2, 3, 4, 5, 6 units wide divided by 2. What is 2 times 6 divided by 2?
6 equals 12 divided by 2 equals 6.
Perfect. You guys are doing fantastic. So let's look at this last triangle that we created. I'm going to highlight this one green so we can all see it. And I'm going to call it triangle number 3. So we have to figure out the area of triangle number 3. So it's 1, 2, 3 units across the bottom. It has a base of 3 and a height of, it's the same height as my square, so that's a height of 9 divided by 2. Say that again. 13.5. Excellent. Okay. So the area of the square that we created minus the area of the 3 triangles. That's what we're doing. So I'm going to write that out so you can see it. The area of the square minus the area of the 3 triangles that we created. That'll help my thinking, okay? So let's see. 81 minus 31.5 minus 6 minus 13.5. What does that equal?
30.
It equals 30 exactly? I love that. So 30 square units. That's way different than the 81 that we first started with, right? It's almost a third of that. How are we feeling? Is this making sense? Okay, so what do we have to calculate next of this same shape? The perimeter. We got to do the perimeter, okay? So I want you guys to plot these points on your graph paper. The coordinates you have, so plot these on your graph paper and we're going to calculate the perimeter. We're going to calculate the perimeter. Oh, I got to plot my points too. I didn't realize that. So -4. This is A, B, C. So draw this one on your pink graph paper that I gave you. Are there any horizontal or vertical lines that we can count on this one? No. So we're going to have to turn it into that square again, right? We are going to have to turn it into that square. Okay. So let's turn it into the square just like we did when we were calculating the area. We're going to turn it into a nice square. And I'm going to label the sides that we are missing. I'm going to call it X, Y, and Z. I do that because ABC for Pythagorean theorem, if you keep using it over and over again and everything is called C, sometimes that's a little confusing. Okay? All right. So can we do it in the same order? We'll do top right, bottom right, and then the left side, just like we did on the last one. So we're going to use Pythagorean theorem. So I have to figure out this measure right here and this measure and put it in Pythagorean theorem. So what are my units? 7 and 9. So that means I have 9 squared plus 7 squared equals x squared. 9 squared plus 7 squared equals x squared. Well, what is 9 squared? 81. And 7 squared? So what is 81 plus 49? So 130 equals x squared. If I want it to just equal x, I have to take the square root of it. So I'm going to write that on my picture. This equals the square root of 130. Perfect. I got that. What about y? Let's talk about our dimensions that we're going to put into Pythagorean theorem to find y. Here's one length. Here's the other length. So what are my units that I'm using to find y? 1, 2, 3, 4, 5, 6 by 2. So 6 squared plus 2 squared equals y squared. Well, what is 6 squared plus 2 squared? 36 plus 4 is what? Is 40. 36 plus 4 is 40. So 40 equals y squared. What does y equal? The square root of 40. Good job, Isaac. So this is the square root of 40. Let's squeeze that in there. Square root of 40. All right. You guys are doing so fabulous. I'm so proud of you. So let's see. Now we got to figure out this right here. So what are our measurements? Well, it's 9 by 3. So 9 squared plus 3 squared equals z squared. What is 9 squared plus 3 squared? Put it into your calculator all at once. It's 90. So 90 equals z squared. What does z equal? The square root of 90. Very good. So our perimeter equals the square root of 130 plus the square root of 40 plus the square root of 90. To the nearest tenth, what is that? You got to make sure when you're doing the square root, like you can do the square root of 130 and then arrow over plus hit the square root again. Otherwise, it's going to smash all of that underneath the radical.
This is what I got.
That's perfect. What did you get? Say it out loud.
I got 21 to 27.2.
Perfect. 27.2 units. Absolutely perfect. Okay, if you need to flip your graph paper over, do that for the next one, because I would have done like top and bottom and kind of smushed my work in the middle. Okay, so I think our last one, oh my gosh, how many ordered pairs are on that last one? Count again. I see 5. Yeah. I see 5. Oh my goodness. Okay. So the first thing that we're going to do on this shape is calculate the area, because I think that that's the easiest and it helps get our brains right. So, what's our rectangle going to have to look like? What are the 2 widest points? And then what is the highest and the lowest? Owen.
The widest points are D and F.
Yeah, D and F. So I'm going to have to kind of do this on the D side and this for point F. What's the highest point?
The highest point is point E.
So I'm going to go right through E. And what's my lowest point?
Lowest point are points G and H.
Good job. So I'm going to erase out my extra fluff that I put in there. But I want you guys to understand how we're making our rectangles. That's the most important part, is just giving yourself something to work with. I'm going to connect my points to D, E, F, G, H, so you can actually see that you have a pentagon. So when we took that pentagon D, E, F, G, H, and we turned it into a rectangle, what have we created? What did we add to that?
4 triangles.
Oh my gosh, like 4 triangles. So we're going to have to calculate the area of the rectangle and then subtract out what? Some triangles, 4 of them. Okay, so let's calculate the area of the rectangle. What is the length of this unit? How long is it? 1, 2, 3, 4, 5, 6, 7. I count 8. Is that what you guys get?
Yep.
How tall is it? 1, 2, 3, 4, 5, 6, 7. Is that what you guys get? Okay, so the area of the rectangle, 8 times 7, well, that's going to be 56. But now we're going to have to do some subtracting. Okay, we're going to have to do some subtracting. So how am I going to find, whoops, I wanted to use a highlighter, sorry. How am I going to find the area of this triangle? We're going to call it triangle number 1. What is its area? I'm going to call on people. So, Victoria, I want you to look at the pink triangle that I just colored in. What are the 2 measurements that we're multiplying together? What is the base and the height of that triangle? I just counted the marks. This is my base. How many units is that? 2 by 4. So 2 times 4 divided by 2. All right, Brianna, so what is the area of triangle number 1? What is 2 times 4 divided by 2? No shout outs. 2 times 4 is 8. Divided by 2 is 4. Okay. Triangle number 2. Owen, I'm coming to you. You can have triangle number 3, Ken. I'm sorry. Triangle number 2. Owen, what are the measurements that I'm using for the base and the height?
Well, for starters, its base is 3.
Yes. And
its height is 4.
So the area of triangle number 2 is 3 times 4 divided by 2. Owen, what is 3 times 4 divided by 2?
So 3 times 4 is equals 12 divided by 2 is 6.
Perfect. Nice job. All right, Ken, what color do you want your triangle to be? Okay, well, I'm choosing blue. So Ken, triangle number 3. Tell me the dimensions that you're using for the base and the height. 3 and 4. Good job. Area of triangle 3 is also 3 times 4 divided by 2. And what is that? Perfect. Triangle number 4. Avery, I'm coming to you for triangle number 4, okay? So base and height. Base and height. What are the measurements that I'm using for triangle number 4? 2 and 4. I think it's actually 2 and 5. 1, 2, 3, 4, 5. Do you see that? Okay, good job. Area of triangle 4 is 2 times 5 divided by 2. Avery, what is 2 times 5 divided by 2? It's, yeah. Can I show you guys something? Look at this. Do you see how a 2 in the top and a 2 in the denominator cancel out? It's just the same thing as dividing by 2. Do you see how 2 in the numerator and a 2 in the denominator cancel out? Okay, use that as a trick. All right, so area, let's see. So we have the rectangle minus 4 triangles. I need to write that. Area of the rectangle minus 4 triangles. Oh my goodness. So 56 minus 4 minus 6 minus 6 minus 5. I know some of you guys are great at mental math. And so if you want to group some of those together, you can. What do you get for this? $35 square units. I love that. How do you feel about that? Who would have thought that you guys would know in Math 1 how to calculate the area of an irregular polygon? Because that's what that is. All of the sides are different. You guys did that. That is super awesome. Okay? All right. On your graph paper, you got to plot these points. On your graph paper, you got to plot these points. Do you want me to list the ordered pairs for you? Okay. So D is the ordered pair -3, 4. E is the ordered pair 1, 6. F is the ordered pair 5, 3. G is the ordered pair 2, -1. And H is the ordered pair -1, -1. Whew. So I'm going to plot my points. Well, after you guys plot your points, I'm going to connect my vertices. And then I'm going to turn this into that, whoops, that's not very straight. I'm going to turn this into that fabulous rectangle that we worked with when we were calculating the area. Remember, this time we're doing the perimeter, yeah. This time we're doing the perimeter. When you look at this shape, are there any horizontal or vertical lines that you can actually count the distance of? Which ones?
H to G.
How long, what is the distance from H to G? How long is that? It's 3 units. So I know that this measurement right here is 3 units. But for the rest of them, I'm going to have to use Pythagorean theorem. So I'm going to label the sides W, X, Y, and Z. Okay? W, X, Y, and Z. So I'm going to start with the triangle W. I'm going to start right up here with triangle W. What are the 2 legs of my right triangle that I'm putting into the Pythagorean theorem? 2 squared plus 4 squared equals W squared. Well, tell me what 2 squared plus 4 squared is all together. I want it all together. I want one final number.
10.
Mm-mm.
No, wait.
It's 20. So 20 equals W squared. What does W equal? The square root of 20. Yes, don't forget that. So W equals the square root of 20. Perfect. Let's look at X. Okay. What are the dimensions of my legs to calculate the hypotenuse X? What are the dimensions of my legs? Go ahead, Owen.
Your base is 3,
So 3 squared,
and your height is 4.
4 squared equals X squared. What is 3 squared plus 4 squared all together? It's 25. So 25 equals X squared. What does X equal? What is the square root of 25? Oh my gosh, the square root of 25 is 5. Oh my goodness, we learned about special measurements of right triangles. 3 integers that work. What are those called? Pythagorean triples. 3, 4, 5 is a Pythagorean. I need to slide over a little bit. Sorry, I ran off the page. A Pythagorean triple. Man, that's super cool. Hopefully we have another Pythagorean triple in here. That would be awesome because then we don't really have to do the Pythagorean theorem. We just know, right? We just know it. Okay. So what about the legs? What are the dimensions of the legs so I can calculate this hypotenuse? 4 and 3. If I use the legs 4 and 3, that means my hypotenuse is what? 5. So y equals 5 because it is also a 3, 4, 5 Pythagorean triple. We love that. Excellent. What about the last triangle? We have to calculate the hypotenuse for triangle Z. 4 and 2. Are you sure it's 4? 1, 2, 3, 4, 5. Yeah. You gotta make sure you count those, okay? So 5 squared plus 2 squared equals Z squared. I want to know what 5 squared plus 2 squared is all at once. It's 29. Good job. So 29 equals Z squared. What does Z equal? The square root of 29. You guys are awesome. So the perimeter equals 5 plus 5 plus the square root of 20 plus the square root of 29. What is that about when you put that into your calculator? It's about 22.8. Did anybody else get that? And you got 19.8? Let's see, 10 square root of 20 is a little bit bigger than 4. So 14 square root of 29 is 5. Yeah, it's going to be 19 something. What did we get? 19.8. I love that. 19.8 units.